The title of my research work is a preliminary study for development of bio-based extended bitumen. Due to high consumption of fossil fuel, with the consequent carbon dioxide emissions, countries around the world have implemented a decarbonization plan by 2070, including India and China. Based on this plan, new techniques are researched that exploit waste material and of-life materials and biomass needed to replace fossil feedstock. This issue affects many industrial sectors, including the paving industry. The paving industry, to become more sustainable, should be reoriented in the reduction of the laying temperature to have an energy gain but also minimize the production of volatile organic compounds, the reuse of materials, for example, reclaimed asphalt pavement, and the development of new binders using waste material of biological origin that can replace the fossil fraction. The last point is of particular interest. From the literature, as can be seen in slide, 4 classes of binder have been defined based on the percentage of fossil source present. Bitumen, 100% of fossil source. Modified bitumen, fossil source replacement less 10%. The replacement is usually carried out with polymeric materials that give the materials an improvement in properties. Extended bitumen, fossil source replacement range from 25 to 75%. And finally, alternative binders in the fossil fraction are less than 10%. If the substitution of the fossil fraction is carried out with biologic materials, the binder falls under the class of biobinders. This work aims to develop a biobinder with a replacement of bitumen percentage of 50%, thus falling in the class of extended bitumen. The experimental plan initially involves the preparation of the extender at the certain process condition of 1 hour at the temperature of 116 degrees to melt the polymer in the mixture in the blend with the high performance mixer Silverson at mix rate of 2000 rpm. Then the extender and the bitumen are mixed for a further hour at the temperature of 160 degrees with the traditional mixer. Finally, the samples are analyzed rheological properties with the DSR, dynamic shear rheometer, with the temperature sweep test and frequency sweep test. The following materials were used to develop the extender. Resin pitch, given the complexity of the molecular structure, give the structure to the material and adhesive properties. Fatty acid methyl esters that increase the cohesion of the materials. SBS polymer provide elastic properties to the materials. These materials, mixed in different ratio, as indicated in the table, constitute the formulation of the extender, which is then mixed with bitumen. The first results obtained are from the temperature sweep test. Temperature sweep test is conducted in a range of temperature between 25 and 120 degrees with heating rate of 1 degree per minute. The frequency is constant. Temperature sweep tests are preliminary tests that are conducted to monitor the behavior of the loss modules and storage modules with the temperature. The trend obtained for the first two biobinders show a similarity with those of bitumen modified with SBS. The frequency sweep test is carried out over a temperature range from 10 to 60 degrees, and at each temperature the frequency applied goes from 0.1 to 10 Hz. Reporting the complex modules as a function of phase angle, we obtained the black diagram, in which if the curves to the different temperature aligned allows to verify the validity of the principle of superposition time temperature. Then build the master curves. In the first two mixtures, the diagram is appreciable. In the last one, the greater presence of fatty acid methyl esters at high temperatures does not respond correctly. The master curves built for the free blend compared with the traditional bitumen black line was also verified by previous rheological tests. The first biobinder AB1 and AB2 have a trend and values of Ge star comparable to that of bitumen, unlike the third blend. And finally, we can say that the three tentative extent bitumens with higher amount of bio-based materials were characterized by rheological tests and showing promising results. The results obtained by temperature sweep test showed similar behavior of AB1 and AB2 biobinders with SBS modified bitumen. The master curves obtained by frequency sweep test of a traditional bitumen was comparable to the AB1 and AB2 biobinders, while AB3 binder exhibit a different behavior than the control bitumen. This is an activity ongoing and is focusing on the full characterization of the proposed extended bitumens, while future study will be addressed on the improvement of the proposed extended bio-based bitumens, changing the raw constituent materials and their mass proportion. In addition, the development of further binders that consist of a smaller percentage of fossil materials has been planned. Thank you for your attention.